Hello, everybody. How you all doing? Hope you're having a wonderful day. We're finally here in December, so and yeah, as we were yesterday, I guess. But you know what really sucks? Being about 2 to 3 minutes away from starting the stream, and suddenly the audio cuts out on your main PC, and you have to reboot it. That's what I'm dealing with right now. The system's just completely blank, and it's actually getting kind of concerning for me now that it's not. The monitors are on. They're displaying black, but nothing's showing up. That is very freaky to me. You might have noticed I actually swapped around my lighting setup a little bit. Got the red light coming from over here, the blue light from over here, my phone giving me a little message. Yeah. Yeah, I don't need to know that. Keeps giving me crappy messages. What the heck is going on? Oh, this isn't good. Monitor's just staying black. Alright, so the plan was to do some WoW programming, because we haven't done that in a while. But if my PC won't boot, I don't know what we're doing. One moment. Do I not have a technical difficulties button on here? Let me see. Okay. It rebooted. Let me sign in. Oh. Hopefully the audio works. Thumbs up. Yes, welcome. Come on, boot up. Oh, what the fresh hell is this? Yeah, I wanted to do programming tonight. I thought it'd be fun. It's we haven't done it in a while. We're going to work on the WoW plugin that we haven't touched in almost 3 weeks, it feels like. But I guess that's not happening, because now my Windows doesn't want to boot. It's just like I get that spinning icon saying, welcome, 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 and nothing's happening. Yes, we're here. You can let us in now. Have to reboot this again. Okay, there we go. We got it working. Yay! Oh, that really worried me for a moment because it logged me in and then it said, "I'm sorry, the user interface surfaces cannot be worked." And then it logged me into a blank profile, and files look like they're missing and everything. So, fortunately, it looks like everything's coming back. Things are getting checked out, and yay, the sound system looks like it's actually working. Let me turn on my headset. And now you can hear me in stereo. Alright. Turn off that microphone, because it's a terrible, terrible microphone. Alright. Let me see if I can get some music up and running. There we go. I had to make sure the speakers were off. Alright. System's still updating. But let me see. I'm streaming.
I do it now.
It's okay. Usually I lock the door. Why didn't I? Alright. Just waiting for things to boot up, like OBS. Turn that down a little bit. Get all these updates for Discord and Gilded out of the way. Alrighty. Looks like things are starting to work. Let me make sure I can get the project loaded. Actually, I need to compile it before I try to load it. So one of the things I tried to do just before the stream started is I'm updating the plugin for 5.1. Right now I'm just trying to get the project to load. Yeah. So it's actually doing a compile right now. You can see that. If we go here. Actually, I probably need to go there. Then you can see it compile. Okay, that little thing's kind of in my way now. Haven't reorganized it for this new camera setup. Let's see if this thing compiles. I don't know, maybe I need to do some adjustments on this. Yeah, undo. Okay, well, I can't fix that unless I grab the keyboard over there, and I'm not going to deal with that right now. Alright, so we're mainly just waiting for this to actually start doing stuff, and of course now it's starting to do stuff, but it's going to take a while for it to compile. Oh, that's right, we got to do that. Suppress this message. And the plugin editor. Which one? WoW plugin editor dot. All right. Or set to engine include order version latest. Will always include the latest order include order. This will potentially cause compile errors when integrating new versions of the engine. I'm okay with that. So, yeah. You can see that little message right there. So let's actually stop this and start recompiling again. Now I don't know if it's going to give me that error with the other editor targets. I mean, there's a chance, but unlikely. Okay. I think file version's okay. I don't know. Maybe it needs to be different. Or maybe it just needs to do its job. Oh yeah, I could have loaded up the old version, but, you know, making this 5.1, that actually solves some of the concerns that we've been having. So if I just make it, you know, a 5.1 plus, I could, in theory, kind of revert the code a little. Make it compatible with, you know, even 4.26 or 4.7, but I'm not going to, because this is basically built for 5. So we will have some compatibility with 5, but I think we're going to try and focus mostly on making it, you know, 5.1 plus. Can you guys hear me well against the music? I'm just trying to figure things out, so. We're going to get some shadow errors here. Yeah, it looks like we're getting some shadow errors. Oh yeah, we're getting some errors, alright. Alright. Asset registry include... Alright, so asset registry module. There we are. Asset registry slash asset registry module. Good. Which yeah, that's correct, I think. A lot of U material issues. You know, a lot of those errors might just go away if, if I get into another one. Error. You know what? I'm going to be over here. Had a whole bunch of errors. You know, it looks like they moved asset registry module into the asset registry folder. So that's what the error was, I hope. Oh, no, we're still getting errors. All right. All right, expressions. All right, so how do I do this then? Add expression parameter, maybe? Add reference, add. Add expressions parameter. Add express Alright, so we have add a expression node that represents a parameter to the list of material parameters. No. Assign, find, flip, get all custom outputs. Has any propagate, cache, remove, update. Okay, so how do you add an expression? How do you add a node, basically? Connect. Alright, well, let's take a look at the documentation. We're going to have to figure that out then. Looks like U-Material has basically changed how it works. Depreciated 5-point use. Create streaming instead. So this is literally the first error that's us. Alright. Okay. You know, this is this is messed up enough that I might have to actually do something different. Please use export text item in container or export item direct. Export. You gonna update? No? Alright, we'll let that be. It's probably still catching up with stuff. Alright, U-Material, here we are. It hasn't been updated for 5.1? Alright, here we are. Expressions. It says it's a public variable of U-Material. So U-Material has no member expression. Expression. I wonder if this is the correct version of that. I don't know. materials, correct? Yes. All right, let's go to this document. All right. Okay, editor, new material. Here we are. Physical materials, blend modes, errata, blend mode, decal blend mode. Then I override material. That's actually going to be a fun one. I don't know if we're ever going to use that. Ooh. A lot of U properties in this. I'm not surprised, honestly. BU full precision depreciated. Precision mode. Shading. Oh, here's the material graph. Okay. All parameters. Okay. Deckgate pal blend mode. Yeah. All right. Fine expression by GUI. Oh, you don't need that. It looks like a whole bunch of stuff just updated in the background. Get all expressions of type. No. Get all expressions of material and functions of type. Has any expressions of material or functions. No. Alright, let's see. Add an expression node that represents a parameter to the list of material parameters. No, that's not what we want. We want to add an expression. Remove expression parameter. Propagate expression parameters. And I just moved my mouse. Great. Oh, direct access to expressions is depreciated. God damn it. So, where else in this is it? You know, so that's all been depreciated. Access to everything I want has been depreciated. Find expression by GUI recursive. Fix feature level. Returns the U expression function output. All right, so yeah, the one on the website has not been updated. Removes the expression from the editor parameter list if it exists and re-adds it. Get expressions. So let's get editor only data. Okay. So if I swap that out to get expressions, that might work. Get expressions. Alright, so replace that with get expressions. Nope. Begin in no, it's get expressions. Get expressions collection. Add expression. There we go. So, what we'll do, copy, replace, all right, so how do we replace that data though? Because that's all been depreciated. As base color, I don't know, let me check this. No, okay. Alright, this is the downside of, doing shit like this. Alright, let's just see what we can do finding this. New material, okay. Class, U editor material only. Get editor only data. Maybe. Alright. Let's give it a shot. Worst it's going to do is say no. Get editor only data dot base color. Okay, perfect. Just copy, paste, paste. Nope. All right. Material color. Expression. Ah, okay. So it's got to be that. Let's see if this is... Yep, this is the same. Get expressions. Yeah, let's get all these first. Okay, yeah, we need to do that. Get collection. Empty. Alright. So that solves that. With these changes, I don't think we can go back to 5.1, 5.0. Oh, you can try, but I don't want to have to do an if-then-else for all of this for if we're in the right version or not. Alright, looks like we got some work to do in material function. That's okay. Error function expressions is not a member. Alright. So function expressions, it'll probably end up being get function expressions or something like that. Alright. Get function expressions. That gets a constant view array. We need like a reference. So function expressions, dependent function expression candidates. Alright, so this is a uMaterial function. Yeah, materials have not been updated. Alright, uMaterial function. Let's peek this. Go to definition. Okay, so we are looking for function expressions. So maybe we should just be looking for expression. Parent function. Yeah, let's actually just try that real quick. Expression. Get expression collection. Ha! Called it. Actually, let's swap that. That. Place all. Add expression. looks like that's going to solve that. ADT, function of file name. Okay, let's try to go BP file name. How about that? Plus file name. All right. WoW import settings. It's having a problem with this. Please use export item in container. All right. Export. Oh, it's probably going to be array. Export text. You know what? That's a warning. I'm not going to worry about it just yet. Import text. It takes a direct property pointer is depreciated. So import text direct. What about if I just do import text? I don't know, that looks like it might work. So you're saying I just have to get rid of inner and it will work? Well, that looks like it was right. Let's do direct. What about inner? F editor style. Okay, that one's gonna be kind of busted, but let's do a build, see where we're at. Maybe we're lucky. We aren't that lucky. No. If you just want to work on it, why don't you work on it over there? I want to work on it, but I want to work on it in 5.1. Which means a little modifications. Oh, we're still having errors there, huh? Error. Added material is not a member. What? The... Oh. There, add material expressions. Yeah, not all open documents. No wonder it's having a problem. Ah. What about the other one? Is that going to have a problem? Probably not, but maybe. It looks like that's going to be a problem. We'll find out. Well, at least the list is a lot shorter now. Alright, so we'll have to straight up get brush. brush. And get brush mesh. FE editor style 5.1. Okay. Include editor style sheet, which is not included actually. Yeah. Get brush, get brush. All right. So something is causing this. I just don't know what. It's not telling me. It's just saying the WoW plugin. Maybe it's up here? You know what? Let's do this. Copy, paste, come here, include asset registry module, and current project. Replace all. Ah, we had 4 that needed to be corrected. All right. Hopefully that will no longer show up as an issue. Ah. Probably still going to have some other functions issues, but, you know, who knows. Maybe this will actually work and we can see if it works in 5.1. It's getting colder out here. Get a nice warm blanket. Oh, it's actually building. Warning. Brush is depreciated. Use F. App. Oh, okay. We're actually getting a depreciated message now. So, yeah. F style. Get brush. Needs to be replaced with. Cancel, cancel, cancel. F app style. Get brush. So there's that. There's a second one, wasn't there? Yeah, there was a second one. Not seeing it. Well, you know, the easy thing to do would actually be to remove that. But we probably need to keep that. Ah, here we are. Ah, you. Alright, let's build it one more time. No more errors, no more depreciation messages. Just good old, or, you know, family fun. Just good old hell on earth. Yeah, that's it. Yeah. I'm gonna need there, and there. There we are. Azeroth. There we go. No errors, no problems. Let's load this up. Now we're going to have to make new scenes. Actually, you know what? I can't remember if I made any custom assets in 5.1 that I would want to carry over, or 5.0, I should say, that I want to carry over to the 5.1 setup. All right. Content, blueprints, basic sky. Yeah, that would be a good one. No, don't move. Copy. You want to copy it. Nope. Nope, that's all good. That's all good. Okay, good. I think we're okay. Ah. We'll see what happens. So there's a number of nice improvements on 5.1 that we're definitely going to take advantage of. Like the fact that we can use nanite on all of our meshes. Because, you know, only the ones that are transparent will be an issue. But we haven't gotten to animated ones, and most of the ones that are transparent are animated or masked. So we don't have to worry about masks ones, at least. At least not yet. Alright. What do we got? A blank world. That works for me. Alright. Well, let's start with a new empty open world. We'll drag our blue sky, our basic sky, into here. And we'll set that to 0. But then we'll also raise it up a bit. Let's say 2,000. There we go. We'll set this up to 1,000. Because we're not going to need to modify things, you know, that big for a bit. Alright, WDT. We'll put that in there. Reset that. There we go. So now we have to actually start doing what, you know, users would do. So, first thing we're going to do is we're going to create a folder called versions. And then we're going to create a 01 underscore WoW vanilla. Actually, we'll go, you know, WoW underscore 01 vanilla. That way it's at the end. Now, we're not going to do too much with vanilla, so let's jump straight to... No. 3, Wrath of the Lich King. Because that's actually where we're going to do a lot of good stuff. Alright. So, world. Actually, no, let's not get into that just yet. First things first, version. WoW version info. WoW 03, Wrath of the Lich King. Open this up. Alright. So we know it's Wrath of the Lich King, the original one. Game content is going to be that one. So is there like a copy? There should be a copy. Nope, doesn't look like it. Okay. So we're going to just go WoW underscore 03 underscore Wrath of the Lich King. And source directory. This is actually where it's going to say, hey, where are all the contents at? And that I'm just going to straight up paste, select. So that's how it's going to be able to get everything. Now, there's a lot of settings in here that we could use, but we're not going to yet. We are going to turn on nanite though, because now we can actually nanite everything. Complex is simple, that's good. Material instance. Oh, did we not copy over the materials? I could have sworn I did. Oh, it may not have processed in time. Well, that's okay. Let's save everything. Alright, we'll save that, and we're actually going to save this level. So we'll call this, levels. New folder. 03. Lich King. Azeroth. Okay, I guess there's Luigi out there. Okay, so we got this. We got Azeroth, and that'll be fine. Actually, you know what? Let's make a new folder. And we'll save this as. Alright, so once the game restores functionality to me, we can move on. Oh, it crashed. Alright, that works too. I wanted to reboot it anyways. Why don't you reboot? Alright, so. Yay. Let's get this booted up again. Now it should actually see the content, all the content folders that we copied over. Which should include the new materials folder. Yep, there it is. So let's see. Perfect. Let's delete those. Force delete. Force delete. No, don't save. All right. Ah, a little close, buddy. So if I set this back up to 1,000, yeah, that's good. All right. So now we need to come down here. We're going to go to world. We're going to go maps. And then Azeroth. And we're going to drag the source folder file in here. We're going to tell it to use that. And there is that. So now we have our ADT list and everything else. We'll save that. We'll assign that, and then we'll place ADTs. There we go. We got all of our ADTs in here. Let's find the one that we want, which is going to be 39, or was it 28? 29. I think it's 29. 29, 38, or 39. All right, 31, 49. I believe that's it. Right there, huh? Let's see. So is it 31.49? That sounds right to me. All right, I'll import that one. Let's see. Texture list, that looks right. Yes, perfect. I'm hearing children in the background and it's hilarious. Alright, so let's get the let's get our usual 6. Round up the usual 6. Well, actually it's 9, but yeah. Import all. Apparently I never got that working. Or, oh, I guess it worked. Let's save everything. Now, the big issue that we've had with generating landscapes, and I'm sorry I've been close up this whole time. One of the issues we've been having with the landscapes is that generating them as a procedural mesh takes forever to save the assets for. So that's something that we need to be conscious of as we're working on this. That said, one of the things we need to work on is actually getting it to load as a landscape, because that would solve so many issues. The good news is we can actually have it load as a static mesh. So there's that. You know what? I'm going to be up here. Or maybe I should be over here. Now, you guys don't need to see the outliner too much. We're not going to be doing too much there. At least nothing that, is going to be important. Alright, saving the assets. So this is the 9x9 tiles that we've been mostly working on with Azeroth. So as we continue to work with this, it will hopefully improve. Whew. Landscape mesh type is set to procedural. I think we're going to want to set that up to either static or landscape, but I don't think I have the landscape code in there yet because I haven't quite figured out how to make a landscape in C++. Alright, there we go. So, for the moment, let's just create a procedural landscape. And there, that should be what we need. That's right, we actually did get the... Oh, you know what? Probably better if I had this update, wouldn't it? There we go. Let's not save. Did I accidentally move that? I can't tell. Ah. Save selected actor. So that's neat. I can actually select the actors. Right click and then save. So the only one I'm not saving is the one that we've already generated a landscape for. This way we won't have an issue coming back to and saying, oh, we have to load up this one. So it's already connected these. That's the good news. So now we should just be able to hit create landscape. And there we go. So this is where we're at. This is a procedurally generated landscape with procedurally generated, fake water. It's not even double-sided. So that's all material choice at the moment. We'll have our own generated water system that we'll do for this. Alright, so if we come here, actually no, let's come here. We'll place WMOs. There we go. So we should be able to say, hey, these farms, import the doodad meshes. Yeah. Alright, and now generate the blueprint. Alright, shaders and compiling. Okay, and there we go. Wow, that's actually too bright. What the hell's going on? Yeah, that shouldn't be that bright. Yeah, let's do some debugging here. Lighting only. What the hell? Detailed lighting? No. Okay, that's our overview. Let's see the lumen scene. Reflection view. No, you're not giving me anything, huh? Okay, that's the shading model. Base color. Material ambient occlusion, which is basically nothing. We're never going to have that. Scene color. Ambient occlusion. Preparing shaders. So this is ambient occlusion as the engine sees it. Okay. So scene depth. Got our roughness, our metallic, shading model, opacity, tangent, world, space, normal, base color. I guess the... Oh, you know what? Did I ever fix that setup? I may not have. Yeah, they're using material instances. But I don't think I ever set the material instance. Well, it looks like it already, got the setup for that, so. WoW material instance standard. Alright, so it looks like it's doing its job, so at least there's that. The question is, why is everything so bright? Basically no light complexity, light density. I have no idea why this is working like that, but okay. Well, the good news is that's, looking correct. That's looking correct, other than the lighting issues. That's correct. And this guy will be correct too. Because we've got this whole blueprint system working, up and working. So, is it just some of the changes that they've made? Is the, lack of a better word, reason for the season? They did a whole lot of work, especially with Lumen and stuff. And this should be a Lumen project. I set it up that way. Okay, you guys are all good? Good. Alright, let's generate blueprints for the blacksmith and Goldshire. Alright, so... No, don't do that. Alright, well, there goes that. Thought I disabled that. Oh, I didn't disable it in this new version. But why didn't it give me a warning? Tricksy hobbitses. Okay, so it looks like everything's working the way we want to. That's the good news. The bad news is we still don't know how to do landscapes, so the saving of these is going to take a long time. The other thing we have to work on is actually, working on exporting the materials. Now, I honestly believe landscapes are the future for our landscapes. We definitely have to make some changes to make that all happen, fairly easily. Yeah. Gonna have to make some new values in here. Format options, here we are. So, we gotta make some more landscape options. So, gonna make a new landscape interpolation. No. Interpolation. That's wrong. I know that's wrong. What is the goddamn value? How do you actually goddamn spell it? Interpolation. There we go. So, interpolation. There we go. All right, landscape, blurb, linear, bilinear. Quadratic. Interpolation types. All right. So linear, polynomial, what's the difference between a polynomial and a spline, though? Is a generalization of linear interpolation. Note that the linear interpolation I honestly don't see the difference. There's a whole lot of math difference, but I don't see the difference. So let's take a look at this. Linear interpolation. That's going to be the easy one. We are absolutely going to use that. Polynomial translation. Polynomial interpolation. Polynomial interpolation is generalization of linear interpolation. Note that the linear interpolant is a linear function. Now replace this interpolant with a polynomial of a higher degree. Substitute. We find that okay. Generally, if we have endpoints data, they're exactly one polynomial of degree, at most n minus ones. The interpolant is a polynormal and thus differential. Oh, it has some disadvantages. Here we go. Calculating here is computationally expensive compared to linear. That's okay. Furthermore, polynomial interpolation may exhibit oscillatory artifacts, especially at endpoints. Ooh. That means where the one where the edges come together is going to be an issue, but I've already thought of that. What we're going to have to do is be able to read the the four around it. So, you know, if only the engine was back up again. My basic thought with that is you know, when we're at an edge, we're going to look and see if we are, you know, what point we are on the edge. If we're at the top left, if we're at any corner, we're going to need to pull three different, you know, yeah, we're going to have to pull all three pieces that are, you know, touching that. We got to grab this one and that one and that one. Actually, no, we probably don't need that one now that I think about it. Although it wouldn't hurt, but that's probably going to be a different interpolation. For most of the non-linear interpolations that we're going to use, we're going to have to pull the two adjoining ones. Otherwise, if we're just on a line, we use the adjoining ones, and we're just going to grab the, you know, the second point in, so to speak. We're gonna see what, you know, the data there is, and we're going to use that to smooth out the edges. At least that's the plan. As far as internal goes, we're just gonna, you know, do that. But the question is, what is the difference between polynomial and spline? Because if you look just at these two points of data, I do not see a visual difference. I don't care if it's computationally expensive. We're using this for a single generation. We're not using it to, you know, calculate it every second. Can estimate local maxima and minima that are outside the range of the samples, unlike linear interpolation. The shape of the resulting curve, especially for very high or very low values of the independent variable, may be contrary to common sense. That is, to what is known about the experimental system, which is generating the data points. These disadvantages can be reduced by using spline interpolation or by restricting attention to the Chebyshev polynomials. Spline uses low degree polynomials for each. Oh, okay, so it's literally the same thing. Yeah, nearest neighbor, bilinear, and bicubic. Those are going to be the two that we have to think about, because we do have to think about this in a two-dimensional sense, not just one-dimensional. If it was one-dimensional, linear or spline, that would be fine, but we have to think about this in a multifaceted kind of way. So either bilinear or cubic. So I guess it's actually technically, technically it's bilinear, but all right. Display name linear. And here we'll make it cubic. Landscape lerp. Cubic. Spline. Oh, trilinear. Well, no. All right, let's see. So, bilinear, bicubic, Barnes. What is Barnes? Barnes interpolation, named after Stanley L. Barnes, is the interpolation of unevenly spread data points from a set of measurements of an unknown function, blah, 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 blah. No, they don't have a visual representation. All right, Bezier. All right, so let's. Do I even want to bother with Bezier? Generates a one-to-one one-to-one map for the WoW. For the landscape. For the landscape's height. Matches WoW files exactly. Gotta spell exactly right. Apparently I can't, though. Smooths out the linear points of WoW's original height data to give a smoother interpolates the linear points of WoW's original height data to give a smoother landscape. We give you less polygon. Less polygonal. Polygonal landscape. And as much as I want to add more, I'm hesitant because more just makes way more work. I mean, here, let's add some ones that I'm absolutely not going to add, but and because of how things work, there. Bezier. Uses Bezier splines to generate the landscape height. Will shrink the landscape a bit. Alright, landscape lerp. What's the other one? Lankos. Let's see. Lanksos filtering and resampling are two applications of mathematical formula. If you use as a low pass or used to yeah, here. We're going to read up on it. We use to smoothly interpolate the value of a digital signal between its samples. In the latter case, it maps each sample of the given signal to a translated and scaled copy of the Lankos kernel, which is a sync function windowed in the a SynC. Some of these are translated and then what? I have no idea what I'm talking about now. Resampling is typically used to increase the sample rate from a digital signal, or used to shift it by a fraction of sampling interval. For example, to resize or rotate a digital image. It has been considered the best compromise among several simple filters for this purpose. Cornelius Lankos. Hungarian pronunciation. Okay, we got the kernel interpolation formula. Given one-dimensional samples. Alright, but what about two-dimensional samples? Oh, look at that. That's an example of Lankos interpolation. Neat. Multi-dimensional, here we go. Lankos L. Oh, fuck. So basically it's that, but then you just multiply it by, x by y. Alright. The Lunagare, yeah. So yeah. Bezier. Actually, let's reopen, because I got to be able to copy the name. Lankos. Uses Lankos algorithm. That is totally wrong, but we're gonna deal with it later. And by later, I mean like right now. That is bugging me. Algorithm. There we go. How did I mess that up so badly? All right. Uses the Lankos algorithm to resample the landscape height data. So these are examples of ones that I probably will not implement, at least not yet. I might later, but just having two is going to be a bit of an upset. But I think it's something that we need to have. So, landscape generation setup, and landscape interpolation type. Interpolation type. Or just landscape interpolation method. Method. Yeah, no method. Landscape interpolation method. Changes. Selects which interpolation method we will use when reading ADT files for landscapes. So we need to actually, no, we'll leave that. All right. How are we doing? That's still bugged. But yeah, there's a lot to do. What about the lunar ray? The lunar ray triangulation. Yeah, that looks like Faranoid, alright. This feels like it's going off in a different direction than what we want. Bitmap resampling. There we are. Yeah, bilinear and bicubic algorithms. Sync and Lankos resampling. Sync remapping, in theory, provides the best possible reconstruction for a perfectly band-limited signal. In practice, the assumptions behind sync resampling are not completely met by the real-world digital images. Lankos is an approximation of the sync method, yields better results. Okay. Bilinear, nearest neighbor, that's, that's just, it adds things jaggedy. But we're going to say everything is linear. That's just the easier method, and it'll provide decent results. Bicubic, however, I think is going to actually provide us the best results. But let's see what else there is. Box sampling. One weakness of bilinear, bicubic, and related algorithms is that they sample a specific number of pixels. When downscaling below a certain threshold, such as more than twice, no, we're not downscaling, we're upscaling. Algorithms will sample non-adjacent polygon pixels, which results in both losing data and causes rough results. Okay, so if we were going down, bit sampling would do. Bitmap Nope. Fourier transform method? Simple. Besides the good conversion recovery of details, notable is the ringing and cellular bleeding from content from left from board. Okay. Edge-directed interpolation. Ooh. Aims at preserving edges in the images after scaling, unlike other algorithms, which can introduce staircase effects. Examples of the algorithm include new edge detect neti, eggy. Okay, yeah. Direct cubic convolution interpolation. HQX for magnifying computer images with low resolution or few colors, usually from 2 to 256. Better results can be achieved by HQX and other pixel scaling algorithms. Vectorization. Vector extraction, yep. Creates a resolution independent vector representing from the graphic to be scaled. Then the resolution independent version is rendered as a raster image at the desired resolution. This technique is used by Adobe Illustrator and others. Deep convolution, Yeah, now they're talking about neural networks. We're not going to deal with that. That's a little bit too much. Okay, I think, the big thing is doing bilinear and bicubic, I think, are going to be the two biggest things. I'm noticing here that, look at bilinear. We're going to use bilinear as kind of a starting point for pretty much everything that we want to do. Bicubic definitely looks better, but notice that we're losing some of these points. So we're going to have to weight the height a little bit more. But we'll still try to do that as best we can. So yeah, technically speaking, we are dealing with 3 dimensions, but and trying to reinterpret that into a 2D method. But it's easier if we just think about it in 2 dimensions, with the height being a black and white image. So this is actually a very simple selection. So, bilinear interpolation. There's the math. Repeated linear interpolation. Yeah. Alright. Still saving. This is why I wasn't saving, because it was just going to take forever. Alright, so let's actually start working in on this. I feel like there were more things I needed to do here, but I can't remember what they were. I'm not sure if Land Coast is actually the right choice for this. Alright, trying to think where would be the best place to do that. Well, we need to start with the most obvious point, is the ADT files. Let's close most of that. So, what we need to do is... Actually, we need to do research first. We already have interpolation that we need to work on. We need to come here. View landscape. Landscape. C++. F landscape component data interface. Yeah, it'll get me close to where I need to be. Alright, a landscape. That's what it was. Okay. So what I want to know is what exactly is the setup we need to do. We need to be able to create a landscape actor and assign the height data to it. It'd also be nice to assign a material to it, or even to multiples of those, files. Oh, actually updating. Okay. But the big question is, how do we do that in C++? I don't know. But we'll find a way. So we'll start with a actor. So we know we need an actor. But I'm also seeing there's landscape proxies too. Actually, reopen, because I think I might have jumped past that. This is basically everything we need. So, proxy. Oh, okay, let's work with this. Oh, a landscape. It comes in from a proxy. Editing layers. Okay, so that tells the current one. These are variables. There's a constructor. Add brush to layer. Add layers to proxy. So that's actually something I noticed is, we're going to need multiple proxies. Yeah, let's take a look. Unreal Engine Landscape C++. Painting landscapes chromatically using C++. U landscape component should have all the things you need. This would probably be the most interested. How to create texture asset using C++. Procedurally generate texture as new asset. U landscape component. Okay. Grass data, height map, scale bias. Material instances? Okay, so we could set the materials. That's good. Fix weight maps. Generate height map maps. Need like an import or something. I don't know. Set height map. Okay. Generate landscape without UI by code. something in my mouth. Can't get it out. It's bugging me. Editor, create landscape C++. Creating landscapes. I know that's not going to be what I want. Create a landscape using C++ or Python. Mm-hmm. Call world spawn actor a landscape and set other info. Okay. Ooh. F Datasmith landscape and importer? Create landscape proxy with GUI. Okay. A landscape. Create landscape. Oh, okay. This is actually almost exactly what we need. Okay, I'm going to move that off to the side, and we're going to start implementing something like this. We're going to do this, I think, in the assets for the ADT. No, not the assets. We need to do this in the actors, which I think are down here. Yeah. Generate height as landscape. All right. Generate height as landscape. There we go. All right. So. Okay. Okay. Yeah. What we might want to do is actually reinterpolate the data first before we do this ADT scale, because might go up and over. I don't know. For right now, we're gonna go linear with the data. So, all right, let's see. T-map, material layers per layer, height data per layers. Where is move temp from? All right, so landscape scale. That's all good, but we need to know the X and Y. So size +1. Okay. So we have our resolution, which actually needs to be an int 32. And we'll come up here and make that change too. So we have the resolution. And one of the things we're going to need to do is build a T-array for our height data. And we're going to take our height array, our height data, set num, and that's going to be resolution times resolution. And the first thing we're going to do is initialize it. It's just going to be a little bit easier. I don't know why we're sending it to that particular value. That looks like a maxed out height value to me. Or maybe it's middle. I don't know. But now what we need to do is go through the height data and reinterpolate the original data to that before we move on. So, this is figuring out our scales, which we're going to need later, I think. All right. I don't know, I'm looking at some of this data and I'm not certain. Okay, how exactly do we interpolate all this to this? So we know the resolution, and we know how many height values they're going to be. So I suppose here's the problem. We have to rebuild this into a 9x9 from a 5x5. Not impossible, but not exactly easy. On the other hand, do we? Do we really have to? I mean, we could just, do a whole bunch of math to get this to calculate out correctly. I'm not entirely certain how, but, alright, well, let's try this. Aww. Well, you know, before we all do this, let's keep all this the same. That's fine. So we'll come down here, and we'll start doing the height interpolation. Are you okay? You're good. All right. Editor. Auto save disabled. Okay, so I need to save everything but the landscape. So that would be everything but that. That all looks good. Save selected. The reason I don't want to save these actors is because that's going to cause quite a bit of time delay for us. Okay, so here's the thing. I know that there are 9 points going across the length of our landscape data. We can reinterpolate that into 9 plus 8, so we're looking at 17 points of data. Now we're going to have to figure out the middle points, but still, that's not terrible. Now, the resolution, well, that's a variable. So, let's see. Because we have to consider not only where it is between 2 points, but where it is between 2 other points. Now the first row is literally the easiest. We can just do a straight up linear interpolation, and it will just, go straight in a line. The one after that, however, we're actually going to have to interpolate it going another direction as well. So suddenly we're bilinear interpolating. So how many points of data do we need to generate? Resolution. So, you know what? Let's actually do a little bit of pre-work with this. Let me bring up the LibreOffice calculator. Which, quite frankly, is the easiest thing to work with. Okay, we're going to use an assumption for medium. I mean, the case for small is the default, so maybe we should do that. So, we'll have... section size, sections per component. I'll just move these out here. And those are our variables. We also need num components, which we know is 16. So that's going to be 16. The reason we chose that one is simple. It matches the chunk number. So we'll be able to know, okay, there are 16 components, there are 16 chunks. Let's get that all to work. So section size is going to be 31. Sections per component is going to be 1. Our resolution is going to be sum of all that. No, not sum. We need to like what's the multiply version of sum? Equals that times that times that plus 1. So that's our resolution. So, height data points is 17. And before I forget, I'm actually going to put in here the height data count. Height data num equals that times that. So that's the total number that we need to deal with. Actually, you know what? Let's move that out there. There we go. Okay, so we have 17 points, roughly, along a single line. And this is our source data. We now need to be able to generate 497 points of data across that. But keep in mind that that is per section. So, if we were to actually, do the entire bit, so this will be height data per ADT. It equals that times 16. So we're actually almost half. That's our good news. So, let's take a quick look at this other code again. Yeah, component count. So, section size, num components, so that's still 16, yeah. Now, I don't know, maybe it would be easiest if we just come through and just calculate it all at once, or we try to calculate it just for each component. Now, I don't know if the height data works like that. I'm not sure it does. I kind of want to take a look at the is it in here? Probably not. All right, Data Smith. Core. Oh, you know what? If I reveal this in open containing folder. There we are. All right, Data Smith. Should be under plugins. Editor. Nope. Importers. Nope. Interchange. Data Smith. Let's just do a search, see what we come up with. Data Smith importer. exporter. Alright, if I did Datasmith Landscape Editor. Datasmith. Ah, there we are. Open containing folder. Alrighty. Alright, not there. Plugins, Enterprise. Datasmith importer, source, Datasmith importer, Datasmith landscape importer. Okay. Single file, flip x-axis. I keep forgetting to switch this back. Because I want to talk to you, and then I focus on this. Whoa. What's this? F landscape import helper transform height map import data? Are you saying all of those values are already figured out? Or all this interpolation is already done? Oh my fucking god, this would be fantastic. None expanded offset. We'll import the data and expand. No. Resample to fit the landscape. There we are. All right, I gotta take a look at this. Transforming internal data. What? Having a separate function for this is brilliant. Okay, in data, out data, current resolution. Go to definition. Because this helper, while helpful, doesn't give me what I need. Alright, here we are. If resample, F, source region, acquired resolution, F landscape resample data. Go to yeah, this is where our magic happens. In region, in destination region, width, height, +1, okay. Output data empty, height, yeah, okay. Add uninitialized, alright. So, we're taking our source width, -1, dividing it by our destination width, -1. To get our scale. And destination. No, source. Which for us would be 9. Destination is B6 -1. Enter. So that would be our X scale. So, destination height, width, old X, old Y equals X and Y times the scale. Looks like floor to int. And then we take either the old X floor to... Okay. So we take x0, which is floor to int on x0. And then x1 becomes the minimum, where we take the minimum value. That's either effectively x0 plus 1, or source width -1. So whatever's smaller is what the one we take. Then we do the same with y. That gives us our x and our x0 and y0. So we have our original 0, 0, original 1, okay. And then we bilerp it. Okay. Let's come back over here real quick. F math. Bilerp. Cubic. Okay. So this is the actual resampling data that we're going to want to basically steal. Although, it wouldn't be terrible to just include this. It's part of the thing. So, landscape config helper. Yeah. Well, let's see what the import code for that is. Wait, what? Did I accidentally close something? I might have accidentally closed something. Okay, no, it was just the search. Alright. F landscape. F landscape helper. Okay, so let's just include landscape helper. Alright, that's not too bad. So, landscape config helper. There we go. So now we can come back down here, remove that. Oh. All right. So now, landscape config helper. So we'll just come here. Oh, wow. Okay. Here's the problem. We've got to reinterpolate a scalar value down to an integer value on top of resizing the data itself. All right. I'm not even sure what they want. Just a T-array, huh? All right. Out data is there. And the in data is going to be that. Actually, let's grab this. All right. So we'll change that up to heights. Switch that up to double. And set all that. So, what about the source region? F_int rect. F_int rectangle. Equals, actually, I already have that data. It's right there. 272. Oh, actually, no, this would be different, wouldn't it? So this would be, oh, shit. No, I can't do that yet. There. Okay, so before we do this, we actually have to go through and generate our new height data. So actually, what we're going to do... Alright. Build... Oh, no. Fuck. Okay. Build lerp. By lerp. Source data. Okay. Gotta use the bathroom. I'll be right back. Where's the FK button? There it is. Okay, so we got to build a bilinear data in the small sense, and then we can resample it up. Although I'm wondering if we shouldn't not do that. Because while it is good code, it does it linearly, and we want an option to do it bicubically. Fractional. Okay. For right now, we're just going to do it with this. Alright, so... Alright. Dump height data double into height data as uint16. Which means we are actually going to need this Z scale. We're going to use as much of the values as we can. At least I hope that works. Alright. So, I'm wondering if I should put this into the ADT thing where I could just do, map chunks height data, and then, or map chunks height data interpolated, or something like that. It's easier to think about it as a square image than it is as a collection of linear values. Problem is, I don't know if that will work. And really, we need to interpolate this with 3 points of data. Because not only do we have to go left to right, we also have to consider the middle point. Or do we? Yeah, we do. I mean, it may be minimal, but will actually make a minor difference. We are going to weight it, though. It's going to be almost a third of the value. So, we got to go through the data. T-array. Let's see. Ridge heights. And then heights are just going to be empty. So now we have the original height data. For you know what? Screw it. I'm going to do what I really didn't want to do and come into the formats and actually check on these a little. Because I know that there's a way that we do the interpolation. Actually, don't we do this for the... No, we don't. Do we? Generate height data as mesh. As procedural mesh. Get mesh data. Go to definition. Get mesh data. Or generate mesh data, I should say. Okay, so it's doing that at an asset level. Also, I figured out what's going on with my tooth. It feels like there's a hair in there. Alright, here we go. This is the data we need. So this is the original data. So how do we do this interpolation? Because we are going to have to interpolate this. Do we just go through here? Oh shit, that's another thing we have to worry about. This is all chunked. So we're going through the chunks. Is that how this is going to interpolate the data, though? Actually, it might. Okay, so we definitely need to figure out a way of doing this that isn't asinine. So horizon, vertical points. Maybe we need to do this the other way around. We know that we're going to have 17 points, so we need to figure out. So, yeah. For, UN 30, no, let's just do N32. N32 X, or Y, rather, equals 0. Y is less than 17. Y plus plus. Copy, paste, change it to X. So this is what we're going to end up with. Actually, is this the best idea? Yes, yes it is, because the other option is trying to map out the points from the generated mesh, and I do not like that concept. I'd rather try to come it up with myself, because then we can actually do some nice interpolations in there. Okay, so let's try to figure this out. So we know that we're going to get a total of 17 values in here. And each one is going to be added to heights. So we need to now figure out how do we get that value out of the original heights. Now the original heights uses 17 across, and then well, actually no, it uses 9 across and then 8 down in a really weird configuration. We need to find a way to interpolate that into a more manageable grid. So actually, let me see if I can find where it talks about it. Yeah. All right, here we go. So this is roughly what we're getting. We have 9 points along here, and then an additional 8 here, giving us 17 total just for this. If we go all the way out to and that's just the first 2 rows. We've got 145 values that we need to interpolate and add new ones in between. So that this row is 17, this row is 17, this row is 17, and so on and so forth until we get, down to here. Which should end up with about 200 and some odd, values. So, for this first one, I need to figure out how to get this point, and a variable somewhere along here. So, first things first, we are starting out at 0, 0, which means the first point. This can just straight up be a simple conversion, And that will set us up to grab the first point. So, alright, y times 17, or no, y times... How do I want to do this? Well, y times 17. No. Alright, 0.1. So, double P1 equals y times 9. Plus x. That's wrong. That's absolutely wrong. I can guarantee that. Because what we can actually do is come over here to map the map assets, and there it is. This is the math we need. This will get us all the points. And this is doing a 9 times 9 section, though. That might be more troublesome. So we know the y's work on that, and the x's work on this. So actually, no, this would not work. Actually, no, that would work, wouldn't it? Yeah. In fact, let's just take this whole thing from here. Okay, so it's 1 to less than 9. Alright, so this will now grab us a point on our little map. Now, from there, if we actually come up here, we can look at how we grab the point height. Point height is actually data from our point number. So maybe we should be copying this. And we'll just swap these out for the other values. Okay. So this is actually grabbing us the points. Oh, god damn, this is troublesome. This will let us get the point values. All right, so all right, so this is probably going to give us better values that we're going to need. We can get through here pretty easily. We're using this for, figuring out triangles and stuff, but that's kind of what we need to do, in the first point. So these would, in theory, point us to the correct point in this chunk. So it would actually point us. Let's see, where'd it go? I don't know where it went. All right, right there. So these values would indicate which point these are. Yeah, we're going to go with this. And delete that. Don't care. That's a rendering thing. We're not worried about that. We're going to have to worry about that later, because we're going to have to go back and do, a painted mask layer, and we can use the skip function on that if need be, or just the holes. All right, so this gets us our points for, this quote polygon. I think. Let's do a log here. Landscape point IDs. 1. It's an integer. 2. 3. Oh. 4, 5. 4, 5. All right, so hopefully that works. It's gonna be troublesome, I tell you that. All right, so close down. Nope, don't save. Don't need any of that. Not at your trouble, Sumworth. This is going to be very messy in terms of logging. But it should work, at least telling us if we're staying within the right, the right range. If so, we can just grab the points we need from here, grab their heights, lerp, or bi-lerp if need be. No, we'll probably, we'll just... Yeah, we'll bi-lerp it. What we need to do is tri-lerp it, really. What's going on here? Oh, it's still waiting. I don't like all these depreciated messages. I don't know how to get rid of them. Exited with code 6. What's going on? There we go. Now, if I do actually make these as separate functions for the lerping and the reinterpolation, I absolutely Need to make them, kind of a global function. Oh, did I mess up here? Oh, I think I did. Let's go with C. For chunk. Now, technically, I probably shouldn't be using C. I should be using, chunk ID. Actually, yeah, chunk ID. I was watching a video recently on how you shouldn't abbreviate variables because it causes problems. And yeah, that's probably a good idea. Get into a good habit for that. I don't even know why I called it XID2, 1, 2, 3, 4, 5. I mean, I understand, their points, but I don't know why it's XID. Wrath of the Lich King, and it's cold in here. Here, let me turn the blues up. Let's see, expand data. Resample data. And really, resample data is going to be what we need. And we kind of need to create our own little function for it. So we can probably, it's like, I like our code for it. I just want to make one tweak, and that's being able to use not just bilinear, but also bicubic. But we're probably going to have to do our own little thing for that, because that's going to be troublesome. Oh, you know what? I just realized this is going to cause a problem here. Alright, what about trilinear? How does that work? Okay. Bilinear interpolation with center point. Five points. resample 5 points to 9. Pandas resample. What? Resample with center. Actually, that could work. That would actually work a lot easier. Slamming doors. What are they thinking? All right, so here's what I'm thinking. The hardest part about this is going to be reinterpolating the 3 points into, the points that we need. What if we didn't? What if instead we bilineared the 4 outside points? So with this example, what if we took... Okay, that's just making it worse. What if we took 1, 2, 19, and 18 and did a bilinear treatment on that? We then create another image, another height layer, where we take the very center of that circle we made, we get that value, and we subtract 10. We subtract 10. We subtract that from 10. We then make another image. Well, I'm using images here as an example. It's how I'm thinking of it in my head. We then make another value map that's black on all sides, and then we linear interpolate the remaining 10 value onto that. We then superimpose that, basically add that, or difference it, I guess. No, damn it, that won't work. What would work is if basically we put the outside, we make the whole thing the same, the level of 10, the remainder, and then we alpha the outside. This is probably a lot easier to explain with an image than it would be to explain with stuff. So let me load up Photoshop while this is getting going. I actually need to set this to my starter project. Okay, so yeah. Let's set this to 100 and 100. I mean, it's a random number. It doesn't mean anything, but it's a reference. So we'll make another one of these, also 100. So we will have basically 2 values. This one is the 4 points we have at the 4 corners. So whatever they may be, So we'll have, like, say a red point. You know what? I want to. So yeah, we have the red point. We have the blue point. We have our green point. And we have our yellow point. So we take these points, we lerp them together as needed. In our case, that's basically, we generate our middle point here, which would be, purple. So we would have our middle point, and we just kind of merge all these together. It would end up looking, for lack of a better phrase, a better example, this is actually how it would look. We'd have our 4 points, and we're interpolating and generating it all in the center. Now, what we would do is then take our middle point, that's an average of all of these points put together. And let's just say, for random sake, that it's this, kind of a aqua color. So, what we would do in, this example is, we now have our, 4x4 landscape, height data. Properly all interpolated and all that good stuff. But we are missing the center point. So the center point, we can say is, like a lighter version of this teal version, because they went just a little bit higher up. So, in order to get this to work the way we want, I'm actually going to do this. Solid color. So, this is we would just basically say, okay, this is it. This is our big color. This is our middle point. We're expanding it to the whole image. So even if we were to overlay this right now, it would just overwrite everything. What I'm suggesting is that we come over here and we actually subtract this value from all this. So doing that would actually make it probably closer to that. We would then come in and just, from the center, linearly interpolate out the outside. So, it'd probably be a little bit more, squarish, with the center parts missing. So, not exactly that, but that's a rough estimate. So what we would then do is we want to take this and overlay it over here on that. Now, I don't know what we would do at this point. I think what we would do is actually do a difference map of some sort. Or an additive map or something. Additive may not work because we might actually want this point to go down. So, yeah, it's not a perfect analogy, but it's a concept. You got to think about it if it's happening with. Oh, you know what? Shader models. Yeah, let's make sure that's set up. You got to think about that happening with height data. It's a little bit easier to think about in an image sense, but the math for it is probably going to be closer to what we want. So, you got to imagine that value would be like between 1 and -1. With the center point being that average color that we found in the middle. Alright, Windows. Allow SM6. Going to switch that up there. And make sure that's set to 2019. Alright, restart now. This will probably have to recompile, but yeah. So that's kind of my concept. Is basically what we want to do is we want to take that middle point and make it just basically a value between our negatives and our positives on the height map. So we want the value that we calculate to be the very center. Or we want the value at the very center to be the we want the value at the very center that's been generated by merging all those others to basically be the middle point. That's our 0 point, and we want to take the point number 10 and actually have that be an offset for that. So I think that's probably what we're going to have to try and figure out how to make it do it. And that's going to make things a hell of a lot easier. And then, of course, we, literally interpolate, that one value that 10 is out to 0 at the very edges of the whole thing. And I suspect that is actually what's going to let us do, all this good interpolation stuff. All right, so there's some stuff. And let me save this. There we go. Okay, so we want to grab this ADT file, and we're actually going to switch it from procedural mesh to landscape. So before I actually do this, I need to open up the output log, which is now on my other screen. And I'm going to hit create landscape, and it's going to get spammed. Yep, totally spammed. But you notice what I'm noticing? It's picking up the point data that we need. Yeah, and this is grabbing our data. This is grabbing the point values for each one of these. So we're getting our first 2 points, our second 2 points, and our middle point. So here's 1. And here, let's where's that? Yeah, there it is. So here we're getting 0.0, which would be this one. 0.1, which would be that one. 0.18, which would be that one. 0.17, which would be that one. And then 0.9, which would be that one. So this is getting the values that we need. That's the good news. So we know now that this is getting us the correct values. We can now grab those values out of the height data. So, all right, so double 0.1 equals going to be a ridge height, index 1. Wait, that's what it was? Index? Yeah. So, what we actually need to do, let's take a look at fmath by. You can actually show up for me by lerp. Yeah, fmath by lerp. Fmath by lerp. Although I suspect I'm going to have to include fmath. Oh, no, this doesn't even include it. That's interesting. All right, so P1. Double. Double point equals. All right, and now we'll find our 4 points. I think I actually need to go that and then that, unless Let's just try this. Because we're looking at this. 0, 0, 1, 0, 0, 2. Okay, so it's actually doing that. So we actually do need to swap these. So this would be 4, and that would be 3. P1, P2, P3, P4. And then we need the fractional data. So basically we need to know, where all this shit is. So, for this first point, .5 and 0. Point 0. There we go. All right. All right, heights. Add. Let's start with a very simple one. .5, 1. Next, 0.5. 0, 0.5, well, actually no, it needs to be 0.5. Okay, 1.0, 0, 0.5, 1. And that is how you turn 5 into 9. Whew! Hopefully that worked. In truth, we're actually only turning 4 into that. So... probably the best way to do the second layer would actually be to do it in 4 chunks or 4 lerps, with one corner being the middle point. So this is actually the one that we want as our neutral point. So, double middle point equals that. And let's actually do that up here. And here we'll... we're going to leave that. That's just easier. Alright, so we have our middle point. I'm wondering if I should put them all as variables and then we just add them up later. Now, the middle point's actually, we could actually, kind of fake that a little. Since this is such a low resolution value. We just do that. And I'm actually going to comment that out and set this to the ridge height, number 5. So, screw all the others. That's how we're going to get it done, at least for right now. So, this should get us our original heights as a double. And now we're going to resample that. So now, what we need to do is actually go through and convert our doubles into a UE5, which I am not entirely certain how to do. But, you know, actually we have this data right here. Okay, no. All right. So, convert double to uint16 C++. Convert double to uint and retool. Is that anywhere near what I want to do? There we are. Casting double to unsigned int. Convert a double to an int and back. Let me try Unreal. uint16 conversions. Oh, is that what you were talking about? Alright, negative signs do exist, so you can't convert to anything. Alright, Unreal Engine. Engine double to uint16. Yeah, okay, that's conversions. Maybe that will tell me something. To bool, to byte, to float, to int, to int64. conversion to unsigned int. I don't know, maybe a reinterpret cast? Int 16. Output value equals actually, let's do this. Equals reinterpret cast uint 16 height data 0 there. Invalid type conversion. It's the same type, so what happens if I tell this to be a float? That's gonna be bullshit now. Why do they have to use a uint 16? That just seems stupid. Wait a second. We're doing 9 points? So why is this 17? Oh, wait. No, not that, but 17 times 16. 272. Alright, so reinterpret 272 into our resolution. But we still need to find a way to convert a double to a uint 16. Okay, that might actually work. So, uint 16, size of double divided by size of uint 16. Mem copy. Is it mem c copy? I don't know. Output value source. size of okay, maybe it is MC copy nowadays, but yeah. Undefined. Oh. Alright, so height data, add output value. What, you can't? What's going on here? At dereference. There we go. Slam. Yeah, save. Oh shit, did I? No, I didn't. I didn't do anything wrong. How dare you insult me? Yeah, I think I want to do a debug here. For height data count? No. Num. For int 32 I equals 0, I is less than the num, I plus plus. Alright, now we log, and what we want is landscape final heights. Actually, let's copy this, copy, paste. Here we'll do the landscape final heights. And then here, we'll do a 3 input and then that. So we'll have the title, then we'll have the listing. And, you know, it's going to be hopefully okay. I mean, we're going to have to sit through about, what is it? 2,000, you know, several thousand. Yeah, 24,000 points on the small setting. But it should give us some reasonable values. It's still going to take a little bit for us to actually get, uh, creating the landscape stuff actually running. But having the final height data, that actually gives us some really good values now. All right. So height data per layers. Okay. So we actually are going to need that. I'm just looking ahead. All right. Everything's saved. Create. And we crashed. All right. What? $289. Resample data, double. If I remove resample data, or just the double part, array index out of bounds. Okay. Yeah, this resample data, that's going to be the tricky part to deal with. Good news is it looks like it's automatically figuring out it's a double. But yeah, whenever you use somebody else's code, you always have to worry about, are you using it correctly? Now, in-source region. That's this guy. Should be working just fine. Source width equals the width plus 1, which would be that. And height. And then the destination. So we'll just find out. Worst case scenario, I have to rewrite this code somehow and fix it. But it looks like we're grabbing all of this data correctly. All right. Create. Crash. Had a feeling. All right, so what's going on? Index array out of bounds. Line 150. Okay. Go to definition. Landscape config helper. That's where we were going. All right. The error was on line 259. So, y0 should be the old y, which is y, times scale, Source height. What's going on here? Source width. And X1. Which is old X1. Why is it going negative? Okay. So resolution, sector size, times component size, times number of components, plus 1. That should always be positive, because there's no possible way it could be negative. So, although, what if the resolution isn't that? What if it should be that? Not quite willing to do that just yet. Alright, let's come up here. Landscape resolution. Percent I times percent I. Which should be resolution to resolution. Alright. We'll debug this. And more than likely I'm going to have to pop over to my folder. And we're going to have to look at the log, because the log is where we're going to actually see the values. Alright. There's the call stack. That's the very last thing that we're seeing. That's a whole bunch of errors. Well, it all seems to be happening within the same moment. Okay, there it's actually importing. Okay, so there's the scale. So what the hell's going on here? The scale is positive. Alright, this is still going to crash, but maybe I'll get some valuable information out of it. Nope, the landscape resolution is correct. So, something here is causing a problem. There's conspiracy here, and I will find it out. Alright, so, the resample the heights. So that's our heights. We want to resample it to 0. What if I don't need that? What if I don't need any of that? I just do that. Heights count %I. Data heights double count %I. So let's see if there's a issue here. We know there's not an issue with these, even though there shouldn't be. So hopefully there isn't. All right. Hopefully this will give us a little bit more data. All right. Out data. So according to this, our height data is wrong. At least that's what things are looking like. Honestly, if we could crack this, this would be fantastic. All right, here we go. All right, so what values do we have for our fantastic giveaway tonight? All right, that's exactly the numbers that we should be seeing. So, source height. Well, source height would be resolution, which I can see is 497. Okay, so height counts, we're getting the correct number. We're getting the 567. We're getting the correct double height counts. So let's actually start doing this. Source res equals F292 or 272 by 272. We'll call this just source res destination res. Actually, you know what? Cancel. I don't need set num at all. We just need that. So I don't think we need to worry about our... that. I don't know why this is having a problem. Resample data, float, or double. Line 159. Now see, right now it says on here it says 187. But notice that comes afterwards. So 159 is not correct. We want the one line above it. So 159 would be that. We're actually looking at that. At least we should be. I'm not sure we are. So old Y, that's Y. Y is 0 to destination height, or just under. Let's do that. Screw it. Even though everything is telling me that our resolution number is correct, because we're getting all the correct values out of literally everything, there is a possibility that having this +1 is causing an issue. I really hope this works. Because if not, I'm not certain what to do, because I can't find a fault in their programming. I'm assuming it's used in a lot more than just my random shitty shit. So more than likely, there's a problem with the data I'm giving it. Now maybe what I need to do is actually set this up to, not have that +1. That would adjust the scale. It would adjust the number of height datas we have. And it would adjust that. So actually, maybe, taking the -1 out of there is a good idea. Same error. Same error. Array index out of bound. It looks like it's not getting a value though. what it looks like. Here, let's take that out. Do I think that's a mistake? Absolutely. That is absolutely a mistake. I don't know how things are going to work with that. But there it is. All right. So something here is not right. It's trying to get an array size. It's trying to get data from an array size. So in data, y0. Y0 is floor to int of old y. Old y is y times y scale. Y could be, anything from 0 to destination, but y scale is source height. So 272. So 272 minus 1 is 271. Ooh, do I need to actually set that to plus 1? Oh, I might have to set that to plus 1. So that would actually be 273. So yeah, user error. Which means, actually, we still want this to be plus 1. Cancel, save, recompile. Oh, I hope this works. If it does, we're ending the stream. If it doesn't, I'm going to get frustrated and then end the stream. I think my Z value's wrong. Yeah, my Z value's got to be wrong. Because it's saying it's 0.2 to get the right height. Oh, you know what? This is probably thinking of it as a 1.0, and we need to actually make it a 100. Oop. Times 100. Alright, I'm going to save it because I want to have the correct Z value. It bugs me. I suppose what I could do is just kind of set 1 to 100. But I think this is probably going to be more accurate. Now that's just a visual thing, so I don't need to worry about that. No, no, no. I mean, I could be wrong. We could be looking at a file that needs to be 0.21 percent high, but I don't think so. I don't think that the landscape variation is that big of a difference. Not for this one file. I was happy I got the math right, though. Mostly. I swear, half of the problem with this is just figuring out how to make it work. And the other half is actually fixing the bugs that makes it work. Alright, here we go. Alright. Yep. Alright, so that wasn't the issue. But at least the Z value is correct. That it's 21% now. That looks more reasonable. Okay, so 259 in data. So we're looking at well, let's pull this up. Did I? Let's close that. Okay. Let's do this math. We know that 272 plus 1, 273 is our y. So we need to find our, so this is, let's see, we're looking at y0, old y, y scale, so source height. So source height destination height is going to be 497. So equals that minus 1 equals that minus 1. Scale equals that divided by that. So there's our scale. So for, y, let's say 3. Let's just see what happens there. So old y equals y times scale. Now y0 equals old y, but we need a 4. All right, and now y1 equals min, I should probably, equals min that versus source height minus 1. So now, index equals that times source width, which is going to be that, plus x, which is 0 in this particular case. All right, let's do the x's here. or have that be 3. So x0, literally the same math. Alright, so we need y divided by scale. Alright. Old x equals that divided by scale equals 4x so floor. Alright, and now the second one needs to be source. Alright. So now plus x0. Alright. 0, 0. No. Index 0, 0. Okay, so I guess we're doing that way. Alright, so copy, paste, paste, paste. So now let's make the changes. So that now instead of x0, we're doing x1. And now instead of y, we're doing y1 and x1. Perfect. All right, so that should be the original data. So 5. Why are we having a problem there? Okay, that's got to be 4, doesn't it? X1. That was weird. Okay. That's better. All right. So, 497. 497. Okay, that's not right. So am I thinking of this backwards or something? Does, source height and destination height have to be reversed? Anyway you look at it, that's not right. Alright. Y plus source plus times... Yeah, that's all correct. Now for us, the source height and the source width are the same, so we're not worried about that. Now for the scale, we just need those two. Destination height. Okay, so what if I put 0 and 0? Okay. 497. Gets us about... like, that maxes us out, just right there. So there's something wrong here. Either in my calculations or in theirs. Okay, old x equals, x times scale. Alright, that's correct. Old y is y times scale. Okay, yes. Scale is the source divided by destination. Both of them are -1. So that should be right. So 497. Why is that wrong? Oh, I'm wondering if their code's wrong now. Okay, y times width. Oh, you know what? That's the index, but no, in b times b. Okay, no, that makes more sense. So these are the indexes. Wait a second. We're supposed to have an index. Oh, okay. Yep. User error. User error. I think we need to go through all the map chunks and then do this. Rather than do it per chunk. Either that or we need to add more data here. But this is presenting us with 576 values. What's that times 16? Uh, 576 times 16. Okay. So what the fuck? So here's what's going on. We, from our source data, should have that many values. We have 512 or 76. Even if we, took these 9 values and multiplied it by 16, that would not give us enough values. So yeah, that would be 576 times 16 for the total thing. That's still only 9,000 values. Am I miscalculating the source height? Okay. Alright, what's the square root of 576? Where's the square root button? No, that's the cube root button. Oh, the square root. $24. So 24 values. All right. Let's try that. It's the only thing I can think of. And the math seems to work out. I mean, you know, there are only 576 values, and you know, maxing this out does get me 576. That's a very small number, though. There's going to be a lot of noise. Well, a lot of incorrect data, I should say. I mean, yeah, we're scaling it up 21 times. And I'm not even sure if I'm getting this information right. I'm going to have to probably dig into this more. 24 seems way too low. Now, keep in mind, that is 24 times, you know, 16, but even so, that should still be pretty... Nope, we're still indexing out. Alright, guys. I don't know what's going on, but that's where we're going to end things for tonight. Which we had better news. This landscape stuff's going to kick my ass for a while. But we got it updated to 5.1. We've you know, got most of the you know, problems dealt with, and now we're starting the road to landscapes. Hopefully, you guys will be able to come back. We'll have to figure out a way to reinterpret this data so that it doesn't crash. Might actually have to find a way of building it up a bit more, making it a little bit more higher res version, because I do not like the fact that it's, you know, 24. And it needs to use up 497. So, yeah. Definitely going to work on that. Alright, that's it for tonight. I'll see you guys tomorrow. Good night, everybody. Oh, starting at 5 p.m. Pacific time. Don't forget to like and subscribe.